Hello everyone, this is Madhura L from Honda section studying in 2nd SEM and currently pursuing Electronic and Communication Engineering. Today's subject is Basic Electronics and the topic is Operation of Zener Diode as a voltage regulator. Let us look into the introduction of operation of Zener Diode as a voltage regulator. A Zener diode, also known as a breakdown diode, is a heavily doped semiconductor device that is designed to act in the opposite direction. Zener diode is commonly used as a voltage regulator to maintain a constant DC output voltage. A voltage regulator is a part of the power source that maintains a consistent voltage under all operating conditions. It maintains voltage throughout power fluctuations and load changes. It can control both AC and DC voltages. The secondary function is to shield the electric circuit from voltage spikes that could damage or fry it. Read further to know more about Zener diode as a voltage regulator, its working applications. Let us look into what is Zener diode. A Zener diode is a special type of electronic component that can control the flow of electric current in a circuit. It's like a valve for electricity. It is a handy device for controlling and stabilizing voltages in electronic circuits, keeping everything running smoothly and protecting other components from excessive voltage. And at the left side is a Zener diode. So at the left anode, it is anode, and at the right it is cathode. At the anode it is always positive and at the cathode is always negative. Zener diode as a voltage regulator. When provided reverse bias feedback, the Zener diode operates as a voltage regulator, generating a little leakage current till a constant voltage is achieved. A Zener diode has a typical current flow from anode to cathode. The Zener diode behaves like a general purpose diode with a silicon PN junction whenever loaded in a forward direction. This forward flow can be reversed if the voltage surpasses a particular limit. The constant voltage aids the Zener diode's voltage regulation. And this is the graph of VI characteristics of Zener diode. At the down Zener breakdown, it is called the Zener breakdown voltage, and at the top it is forward bias region. For silicon, the cut-in voltage is 0.3 volt, and for germanium the cut-in voltage is 0.7 volt. And the symbol for this is also given. We can see that the Zener diode has an area in its reverse bias characteristics where a continuous negative voltage emerges independent of the current that flows through the diode from the VI characteristic curve. Even when the current changes dramatically, the voltage remains constant. A Zener diode's capacity to manage itself can be utilized to regulate or stabilize the voltage source in the face of supply or load fluctuations. Because of this feature, a voltage regulator can be made out of a Zener diode operating in the breakdown zone. The Zener diode's capacity to manage itself can be utilized to moderate or maintain a voltage source in the face of supply or load changes, because it can be utilized in the simplest forms of voltage regulator applications. The fact that now the voltage across the diode inside the breakdown zone seems to be almost constant turns out to be a significant feature of the Zener diode. A voltage regulator's job is to deliver a constant voltage to a load parallel connection with it, regardless of supply voltage waves or load current fluctuations. Working of Zener diode as a voltage regulator. The capacity of a Zener diode to keep a constant voltage regardless of changes in source or load current is critical in this application. A voltage regulation device's general role is to give a constant output voltage to a load connected in parallel to it, regardless of variations in the load's energy drawn, which is load current, or fluctuations and instability in the supply voltage. If the current remains within the limit of the minimum and maximum reverse currents, the Zener diode will produce a constant voltage. To restrict the current that flows through the Zener diode, a resistor Rs is connected in series with the diode, and also the input voltage VIN is connected across as shown in the image, and the output voltage VOUT is chosen to take across the Zener diode with VOUT is equal to Vz, because the reverse bias features of the Zener diode are required to control the voltage. It is wired in reverse bias mode and with a cathode linked to the circuit's positive rail. And this is a circuit diagram for the Zener diode. Whenever the load is connected, a small value resistor would result in a big diode current and electricity, which would raise the power dissipation need of the diode, which could exceed the Zener diode maximum power rating and harm it. The value of the resistor can be determined by the formula, that is Rs is equal to Vin minus Vz divided by Iz, where Rs is the value of the series resistance and Vin is the input voltage and Vz is Zener voltage. Using this method, it is simple to assure that the resistor value chosen does not result in a current flow greater than the Zener can tolerate. One minor issue with Zener diode based regularity circuits is that although attempting to moderate the input voltage, the Zener might generate electrical noise just on the supply rail. Although it may not be a problem in most cases, a big value decoupling capacitor placed across the diode may address the problem. This helps to keep the Zener's output stable. Applications of Zener diode as a voltage regulator. The following are some of the most important applications of the Zener voltage regulator. First one, within the emitter follower regulator, a Zener voltage regulator is used. Second one, it is utilized with a modest load current range and maintains a steady output DC voltage. Third one, it is used to control or change the circuit's output voltage. Fourth one, it is employed in analog and digital circuits that need to be precise with their reference. Fifth one, it is utilized in current source and sync circuits. Sixth one, it is used to fine-tune linear and switch power supply voltage and current. The last one, error amplifiers use it as well. So, thank you everyone for watching my video and please do like my video.